Welcome friends and welcome to my channel. So today I'm going to start a new lecture on dynamic programming that will be easy to understand and you can follow this up. So basically programmer thinks dynamic programming is very difficult topic, but it's not that way. So basically what they did, they started with a difficult problem and try to solve that. So if you start with difficult problem, that will be difficult only. So in this lecture I will start with a small problem and uh, I will give the idea how to think and how to break that problem into smaller sub problem and try to solve that. So we'll start that by one example of Fibonacci. Okay. So basically what is Fibonacci? Like for n equal to 1 and 2 value will be 1, or from 3 will sum previous two element, like third element will be 1 plus 1 2, fourth will be 2 plus 1 3, fifth will be 5 5 8, then 13, then 21, like that. Means we'll sum the previous two value. So you have to write one method for Fibonacci where we'll uh, give a value n and you have to return that nth uh, nth value of that Fibonacci series. Like if we give 5, then 1 2 3 4 5, 5 will be value 6, then 8 will be your result. So let's write some method for Fibonacci. So public, it should return integer and will call from main method without creating that object. So static I'm making Fibonacci. It will take some integer as argument. And what will be the logic? So simple logic will be, if n less than equal to 2, it should return 1. Okay, or for rest of the value it should return Fibonacci of n minus 1 and plus Fibonacci of n minus 2. Correct? So it's simple recursive approach. Like we divided this problem into, you can think simply, like if you try to find Fibonacci of 3, then Fibonacci of 3 will be Fibonacci of 2 plus Fibonacci of 1, simply. And from here we'll call this method and try to find the value. So if you call this method from here for Fibonacci of 5 and run this program, so value is coming 5, that is correct only. If you 6, then it's coming 8, correct. If you take 7, it's coming 13, it's correct only. If you try to find some larger number like 50, it's taking time. So because of this one, concept of dynamic programming came. So we'll understand why it's taking so much time. Now go to this recursion tree visualizer. So in case of Fibonacci of 5, if you try to draw the recursion tree, So Fibonacci of 5 will be what? Fibonacci of, for Fibonacci of 5 we have to find Fibonacci of 4 and Fibonacci of 3, correct? So sum of this one will be this one. Similarly, Fibonacci of 4 will be Fibonacci of 3 and Fibonacci of 2. Sum of this one will be 4, like that. So for 5 we are calculating this much step we are going. Similarly, if you increase like Fibonacci of 6, so tree size will be big. Similarly, for 7, tree size will be little big. For larger number like 50, tree size will be like very big. So for computer programming it's difficult to find that much. Here if you see, like for n equal to 50, sorry it's not giving, here only if you see n of 50, so it will take much time and so it's giving the limit of 256 recursive call was exceeded. Like it's become very big tree, so it's not easy to, it will take time to make that recursion tree. So what would be the solution to solve this problem? So now we try to find our some like duplicate part or something in code, then we try to figure out and what we can do. So we'll go through this. So if you try to see this tree, you see 4 is here, 4 is also here, 4 is also here, likewise 3 is also here, 3 is also here, 3 is also. So if we store the value of this subtree one time, then we don't need to calculate this one again. We can store somewhere. If we want Fibonacci 4, we can get from here. So this concept is called memoization. So we'll store that value somewhere, and whenever we want that value, we can use it. Like here only 5 is 3 times. So if you store Fibonacci of 5 somewhere, then we can use that one. Similarly, if you store value of 4, 3, everything. So we'll see how we'll do this in code. So here in same function, we'll now do memoization. So for memoization, what we'll do, we'll create one variable map or something like that. So in Java we'll create some hash map, okay, and its key will be integer only and value will be also integer only. Okay, I'm keeping its name as memo because I'm doing memoization. So now what we'll do, here instead of only returning, we'll store value of that inside our memo map also. So memo dot put key will take n and value will put as 1, like value of that Fibonacci series, okay. Or here instead of return, what we'll do, we'll put this value memo dot put actually I'm storing that value inside it, okay. and will return memo dot get n. Okay, and also in first line we have to check if memo has already that key, then no need to calculate that value. Memo dot contains key in map will check, and in that scenario will get the value from memo map and return that value. Get and okay, return that value. Return, we have to add a return statement. Okay, so basically what I'm trying to do, first I'm checking if memo has already, in this case if memo has already value of 5 or 4 or 3 something, then no need to calculate that thing again. We'll simply return that value and use in that recursion. Or here we have to call that memo, so we have to define one hash map key pair key value pair will be integer only, so integer new hash map okay, and we have to pass in that concept. Now we'll run that value. Syntax is not correct, I think. Class has more. Simply map we can use. Oh, sorry. Hash map also we can use. We have to import that java.util. Import java.util.star. Okay, because hash map is java util. Hatch key. Okay, we'll see that. Key set contains key, something is there. It's correct only. Contains key. Okay, now if you run, here also we have to pass that memo, because we are calling same function now. So if you run, I'm getting that value like for 7, what it should be 13 or 21 something, say 13. It's coming. If you calculate for big value like 25, then also because now it's not calculating that value again and again. It's like we memorized value. So if you see, if you want to calculate, like in case of 25, it will calculate every value only once, and then it will take that value whenever needed. It's coming big only. Okay, 8 only I will check. Huh. So if one time only it will calculate everything, like to calculate one time, if whenever needed it will return from first line only. Like two is stored here. If 2 is already there, then directly we have to not calculate again. So this is basically mm, how to approach a problem. So next lecture we'll see some more concept, some more question like factorial and all, and slowly we'll understand the concept of dynamic programming, like how to approach a problem like that. Thank you.